Hi everyone and welcome back for a new Spring Boot video. Today we are going to build a Spring Boot application using MongoDB. As you probably know, MongoDB is a very popular NoSQL database which is gaining a lot of momentum. There are a lot of companies and a lot of projects that use MongoDB as their database system. And I think it's really cool to see how MongoDB plays with Spring Boot apps. So we're going to build an application from scratch, and we're going to perform the basic CRUD operations and see how that goes. Okay, so without further ado, let's jump right in and write some code. We'll create a new project. We'll use the Spring initializer, and now we need to fill in this form. RC for main encoder, Maven project, we'll call it Spring Boot MongoDB. I can add the demo as well. And now we can select our dependencies, and we just need web, and we need to go to the NoSQL tab, and from here we can choose MongoDB. And for now, these are all the dependencies that we need to get started with a Spring Boot app with MongoDB. Okay, hit next. I need to pick a folder, hit finish, and now we have our project structure. We can go ahead now and write some classes. We'll create a simple application that manages hotels. We'll have a hotel class with basic properties like ID, name, and price per night. A hotel can have a single address, and also a hotel can have a list of reviews. Of course, address and review, they are different classes themselves, and together these three objects, hotel, address, and review, form an aggregate, and the root of this aggregate is the hotel entity. So in MongoDB, when we persist a hotel in the database, the whole object graph gets stored as a single document. There will be no relationships and no multiple collections to store these various classes. And now we can actually start and write some code. I have added the three domain classes that we discussed about a little bit earlier, the hotel, address, and review. Let's take a little look at them before we proceed. So we have our hotel, we have an ID, name, price per night, an address, and a list of reviews. And then we have a constructor and some basic getters. So nothing fancy. The address, we have city and country, and again, two getters. And the review, we have username, rating, and if the review has been approved or not. And of course, we have getters for each of the fields. Before we move on, we need to add the MongoDB specific annotations. So the hotel is our aggregate root, so this is the entity on which we'll apply our annotations. The first annotation that we need to add is @document. Basically, we are letting MongoDB know that this object should be treated as a MongoDB document and stored in a collection. And optionally, we can pass in the collection name. In our case, we'll name this collection hotels. Then we have an ID field, which we need to annotate with ID. Okay, and one important thing to remember is that in MongoDB, the ID is not an integer value. MongoDB by default assigns some GUID-like structures as IDs. There is a special type in MongoDB called an object ID, and that's what MongoDB uses internally to store identifiers. It's not like in relational databases where you have a sequence of numbers. So that's why we have an ID field, and that's why the ID field type is string and not int or long or something like that. And it's pretty important to be aware of this. And that should be it. So we only have these two annotations. One thing that we could add is, for example, an index. Assume that we want to make some filtering on the price per night and we have a lot of hotels in our database. Then in order to speed up the process, we can add indexes on various properties. So we can say indexed, and we can even give it an order direction, index, direction ascending. Okay, and now when hotel entities are stored in the MongoDB in a MongoDB collection, the price per night property shall be indexed in ascending order. So each time you want to make a filter on price per night, it should work pretty fast. Now, of course, indexed is an optional annotation, but I just thought I'd show you some of the Mongo specific ones in this video. Okay, now that we have our domain, we can add a MongoDB repository to handle the CRUD operations that we want to perform using this application. So we'll add a new class. Actually, it's going to be an interface. We'll call it hotel repository. We need to annotate it with repository. So far is the exact same thing as a JPA repository. So we have an interface, we annotate it with repository, and now instead of implementing JPA repository as we would if we were using a SQL database, we need to extend a Mongo repository. Okay, and we need to pass in two types. One type is the type of the entity that we want to store, and the other type is the type of the ID, which in our case is string. And that's it for our repo. We still get the generic methods like find all, save, delete, and things like that. So regarding this, a Mongo repository is extremely similar to a JPA repository, and even the methods have the same name. And I think this is a pretty cool thing, because if you have applications where you need to work with two databases, then there is consistency across naming. You don't have to learn another interface to work with MongoDB. It's very consistent across SQL and NoSQL databases, and I find this to be a pretty cool thing. Okay, now we have our hotel repository. Let's create a database header and insert some documents into our MongoDB collection. We'll call it DB header. Okay, this is a component, and it's going to implement the command line runner interface, which basically means that when our Spring Boot app starts, then this command line runner shall be executed automatically by Spring. Okay, so in here I want to add some hotels. Okay, let's start. Okay, I'll say hotel. Let's say Marriott new hotel, and now we have a couple of things that we need to pass in as arguments. The name of the hotel, the price per night, let's say 130. What else? An address and a list of reviews. Okay, we'll say new address, and we'll just say this hotel is in Paris and the country is France. And we need to add some reviews. So we'll use arrays as list, and now we'll create some reviews. And let's say John with a rating of 8, and this is not approved. And then we have another review. Say Mary, index of 7, and this one is approved. Okay, we have a new hotel, and now I want to create 2 more hotels. I'll just copy and paste this because I want to move a little faster. Okay, we need to create Ibis. A price per night can be 90. This can be Bucharest, Romania. And let's say Teddy. Okay, and we can remove this one just to make them a little bit different. And let's add our 3rd hotel. Let's say Sofitel. And let's add a price of $200. let's say, I don't know, let's say it's in Rome, for example. Let's have a review. No, actually, we'll not add any reviews to this one. Okay, we'll just say new. Okay, so no reviews. Okay, we have 3 hotels, and now I want to save them in our database each time our application starts. The first thing that I need to do is we need to drop the existing collection if it exists already in the database. Then we need to insert these 3 hotels. Now, of course, this behavior is optional, but because it's a demo application, I want to, start with a clean database each time I run my app. So in order to do this, we need to add a reference on the hotel repository that we created a little earlier. We'll have hotel repository. We'll add in a constructor. Okay. We don't have to annotate with AutoWire because you're using Spring Boot 1.4, and if you have a single constructor, then we can just leave things without any annotation. And now drop all hotels, and we can say this hotel repository, and I think it's delete all. Okay. And now add our hotels to database. We can create a list of them, so we can group our hotels in a list, just so we don't call the save method 3 times. And we can say Marriott, Ibis, and Sofitel. And now persist them with the hotel repository, save, and we pass in a list of our hotels. Okay, so this is our database header. The last component that we need to create is our controller. We'll call it hotel controller. It's a REST controller. And we can say request mapping hotels. We have a dependency on the hotel repository. Okay, and let's create a method that will display all the hotels we have in our database. So we have a public method, list hotel. We'll call it getAll. Okay, we need to annotate it with get mapping because you're using Spring Boot 1.4. And now we'll say list of hotel. We have our hotel repository, and like I told you earlier, we have the find all method. So the naming is identical to the GP repositories. And now we return the hotels we have stored in our database. Okay. We have all our classes. Now I believe we still have one thing missing, which is the application properties. And in the application properties, we need to add the connection string, to MongoDB. We need to let our application know how to connect to MongoDB. And I have them stored in here because I don't want to know them by heart. Okay, so we have spring data.mongodb.host, and we have localhost. We have spring data mongodb.port, which is the default port. And now we need to define our database, and in our case we'll call it hoteldb. One thing that you need to know is unlike using H2 or HSQLDB, which are in-memory databases, in Mongo we cannot have an in-memory approach. So in order to make this application work, you actually need to have MongoDB installed on your machine, which is exactly my case. I have MongoDB. I also have RoboMongo, which is graphical user interface for MongoDB. Okay, I'll delete I'll drop all my databases from MongoDB just so we have a more clear view on how our application will behave at startup. And now we can start our app. So we have everything we need. We can go ahead and hit run. Okay, our application started. We can go to RabbleMongo, hit refresh, and we see that we get this hotel DB, which was not there, which did not exist. So our application, the database header started, and it created the hotel DB, which is the name of our database, defined in the application properties. And now we have, a list of collections in our database. In our case, we just have the hotels collection. And the hotels collection, it's the name of the collection that we specified using the document annotation. So it's hotels, and therefore we get a hotels collection. And here we have 3 objects, which are the 3 hotels that we inserted in the database: Sofitel, Ibis, and Marriott. And this is the result of starting up our application and running the database seeder. Okay, and now if we go with Postman, I should be able to say local host 8080 hotels/all, and we should get a list of all the hotels, and there they are. Okay, so our seeder is working and our hotel controller is working. Next, I want to show you how we can implement the basic CRUD operations, delete, insert, update, and the most important of them, filtering, because filtering is a little bit different than the standard JPA approach, and I think that's the most interesting part of using MongoDB with the Mongo repository. Okay, so let's get to work. Let's start with the insert method. I have a public method. I'll call it insert. Okay, and we'll receive an object in the request body, an object of type hotel. Okay, and now we can say this hotel repository, and we can use the insert method available on the Mongo repository, and we'll pass in the hotel. We also need to annotate this controller method with a put mapping. Okay, because we will use the verbs, the REST verbs. So we have put for insert, post for update, delete for removal, and then get mappings for filtering and display of hotels. Okay, and now we can move on to the update method. We have update. Again, we'll receive our object in the request body, hotel, and again we have a built-in method on our repository called save, and we'll pass in the hotel, and we need to annotate it with post mapping. Now, before we move on to the delete method, I want to point out a difference between the insert and the save methods. The save method works like an upsert. So if the hotel you pass in doesn't have an ID, then the save method will insert that object into our MongoDB collection. If the hotel that we use has an existing ID, then MongoDB will update the document with the given ID with the new values inside the new hotel object. So save works like an upsert. It can perform an insert or an update. Whether insert just inserts data. Okay, so in here I can also use save if the hotel that I pass in doesn't have an ID. But I like to keep the distinction between insert and update. So I will not use save, as a universal way of inserting or updating something. And I just want you to know this thing because in some examples, you will only see the save method being used. Okay. And that being said, we can now move on to the final method, which is delete. And this time I'll just receive a path variable with the ID of the hotel that we want to remove, and the ID is a string. Okay, and again we can use the repository. We can say this hotel repository, and we have delete, and we pass in the ID of our hotel, and we can use the delete mapping, and we need to define the path variable here as well. So we have localhost 8080 dash hotels dash, and we will give an ID, and then that ID will be translated into this string variable over here. Okay, we have insert, update, and delete, and now we can play with them and see if they work. I'll restart the application, and then we'll use Postman to send a delete request, a post request, and a put request. Okay, for a Postman, I want to extract to see all the hotels again. So I have 3 hotels, okay, Marriott, Ibis, and Sofitel, and I want to delete Marriott. Okay, so I need this ID over here. I will create a new request. It will be a request to localhost 8080-hotels, and now I'll paste in the ID, and of course I'll use the delete verb. Okay, and now if I hit send, okay, and I go back to my previous method where I see all the hotels and I refresh it, I see that I only get 2 hotels, Ibis and Sofitel. Marriott has been successfully deleted. Cool. Now let's insert another hotel in this collection. Okay, and I want to open a new tab. We'll use post, and I will say localhost 8080/hotels. Okay, and now I want to send the body of my request as, you know, JSON. I don't really remember if it's raw, I think. Okay, and it's not text, it's JSON. Okay, so I'm making a post request to localhost 8080/hotels, and inside the body I'm sending a JSON object that represents a hotel. I will delete the ID because I don't need it, it will be automatically generated, and we can say golden tulip. Okay, the price per night is 99, and the address is I don't know, let's say Budapest, Hungary. Okay, and I can send in this request. Cool. And now if I go here and update all my hotels, I get Ibis, Sofitel, and look, we also have the new hotel that we've just inserted. Okay, and now let's say I want to update something. I want to update the price of Sofitel from 200 euros per night to 150 euros per night. Okay, well, I'll copy this object and we'll create a new request. It's localhost 8080/hotels. It's going to be a post mapping. Well, actually, it's a post mapping. Sorry. And again, we'll have to modify the body of our request. We'll use raw. We'll select JSON, and inside we'll add this. So I have to pass in the ID now because I want to update an entity, and I just want to change the name. So I can say 99. Okay, and the rest I leave it as it is. Okay, I'll hit send, and then if you go here and refresh, we'll see that we have Sofitel with the same ID, and only the price has been modified. Okay, at this point we have created 3 methods for insert, update, and delete, and now the most interesting part is filtering, and we'll cover that in the next part of this video. Let's start with the most basic filter, find by ID. In order to implement find by ID, we need to go and modify our repository interface, and we'll add another method that will return a hotel. We'll call this method find by ID, and we'll pass in a string ID. Okay, and now in our hotel controller we need to create, a get mapping. We have a public hotel get by ID, and we will receive a path variable with the ID that we want to remove. The path variable will be named ID. It's going to be of type string. Now we can simply call the repository with the method that we just created. So the hotel that we're looking for, you can find this the repository, find by ID, and we'll pass in the ID. Okay, and then we can return our hotel. And now we need to annotate this with get mapping. Okay, and it will be, localhost TTT hotels, and we need to pass in an ID path variable, and it should work. Okay, let's continue with another, simple filter. Let's say that we want to find all the hotels where the price per night is less than, a given price. For example, I'm interested in hotels where the price per night is less than 100 euros. Okay, so IBIS corresponds to this description. And the process is the same. We go to our hotel repository. We need to create another method. Only this time we'll return a list of hotels. Okay, and we are using the convention find by. We need to continue with the name of the property that we want to use for the filter. So it's price per night. And now we need to specify the filter name, less than. And now we can pass in, a max price. Okay, and we need to create another get mapping. So we return a list of hotels. We'll say get by price per night. Okay, and again we're using a path variable called max price. It's going to be an int, and we can retrieve our list of hotels. This hotel repository find by price per night less than, and we pass in the max price, and then we return the hotels that matched our criteria. And again we can use get mapping, and we can say /price, and now we can pass in max price. Okay, so we have two simple filter methods, and let's see if they work. Okay, we'll fire up application, and again we'll use Postman to perform these two get requests. And looks like we have an error. Okay, let's see what it is. Error creating Vim database seeder. I'm guessing it's something with the repository. I think it's something wrong. Okay, price. Oh, okay, so I misspelled my hotel name. Find by price per night, not night. Okay, my mistake, and we need to replace this here as well. Okay, and now we can relaunch your application, and because the methods in the repository are okay, we shouldn't get any more errors. Okay, the application started. We'll use Postman. Okay, we'll refresh the list of hotels, and let's say I want to find Marriott. Okay, we'll use a get request. It's localhost 8080 /hotels, and now we need to pass in the ID of Marriott. Okay, and we'll send this request, and the response is we receive the hotel that we were looking for. Cool. And let's do the same thing about price per night. So I want to filter all the hotels where the price per night is less than 100, and I should get only IBIS. Okay, so we have hotels dash price, and we specify the maximum price. We hit send, and of course we get IBIS. Okay, if we modify this to 150, for example, and we hit send, then we get IBIS and Marriott. Cool. So our basic filters are working. Now let's try a more complicated filter, because up until now, we have filtered only on, the root properties of our hotel object. But what if, for example, we want to filter, by address, and because you're using MongoDB and this object graph address, does not have its own collection. Address is a component of hotel. Now, if you want to filter by city, for example, let's say all the hotels that are in Paris, then we cannot use this, convention that the Mongo repository has. And we need to find another way to implement our filters. And luckily for us, we can do that by using a query annotation. Okay. So up until now, we have used, convention methods, and now we'll use something a little bit, more advanced. As a side note, you can find more about these conventions, about the methods that you can implement in the repository if you go to the Spring documentation page. So docs.spring.io/springdata/mongodb/docs, and here in the Mongo repositories page, you can find, all the filters that you can apply, and you can see examples of various repository methods and how they translate into Mongo query language. Okay, so it's exactly what we used. We used find by ID, and then we used the less than filter, and we created a find by price per night less than, a maximum price. So we didn't do anything out of the box. We just used the standard conventions in the Mongo repository. Okay, so like I said, we want to create a new filter on address. Okay, and it will also return a list of hotels. And now we can call this method, however we want. Okay, we'll say find by city. Okay, and we'll pass in the city name, which is a string. And it will not work out of the box. Like I said, we need to do something extra and annotate this with a query annotation. And inside the query annotation, we can specify the value for our query. Now, if you were using JPA repositories, this would have been a JPA query, or maybe a SQL query. But because we're using Mongo, we need to use the Mongo query language. Now, of course, if you don't know, the Mongo query language, you can go to mongodb.com and read the documentation page, or you can check out a series that I've just created. It's called MongoDB Queries, where I illustrate, the basic usages of the Mongo query language. And like I said, I want to filter by address, so we'll define our MongoDB query, which is address.city, and we'll use this as an equality operator, and then we'll pass in the parameter, meaning the city. And just to prove that it works, I'll go to RoboMongo. Okay, I have hotels, and now I'll paste in the exact same filter. Okay, so address.city, okay, equality operator, and I say Paris. Okay, hit run, and now I get a single object, which is the Marriott hotel, which is in Paris. Okay, so it's a standard Mongo query. Okay, and it's exactly what we used in our query annotation. And now we can go to our hotel controller and implement this method. List hotel, we'll call it get by city. We'll use a path variable for the city, which is a string. And now we can say the list of hotels that we're interested in. We use the repository, and we use find by city. We pass in city, and then we return the list of hotels. And of course, we use the get mapping, and we say we'll filter by address, and we pass in the city. Cool. Okay, and now we have this implemented. Let's see if it works. Okay, we'll relaunch the application and use Postman. Okay, the application started. We use Postman, and I want to perform another request. It's a GET request on localhost 8080/hotels/address, and now I'm using Paris. Okay, I'm sending the request, and we have the hotel that we were looking for. Okay, so this new query works as well. Although the query annotation is pretty powerful because it allows us to perform more advanced queries using the Mongo query language, it does have its limitations. We've used a very simple query here, and when you have more complex queries, then the amount of strings that you need to write will increase. And another disadvantage is the fact that you're relying on strings basically to define your queries. You don't have IntelliSense, you don't have code completion, you can mess things up pretty easily. And for me, it's not a pretty flexible approach. So wouldn't it be great if we had some way of querying a Mongo database in a typed manner, without using these query strings? And the good news is that we can. So there is another library called Mongo QueryDSL, which enables us to write MongoDB queries, complex queries, in a typed manner. But it's not integrated into the standard MongoDB starter. So we need to import we need to modify our POM file in order to use it. Okay. So let's see how we can do that. Like I said, we need to go to our POM file and we need to add two things. First, we need a dependency on the Mongo QueryDSL, and I don't know it by heart, but this is it. Okay, we'll paste it in here. So the artifact is QueryDSL MongoDB. The version is 4.1.3, and this is the first dependency that you need in order to get started with the Mongo QueryDSL. And then you need to add in a plugin, for this, because the Mongo QueryDSL works like this. It scans your entities, and each time it finds classes that have MongoDB annotations, it generates other classes for queries. So for example, in our case, we have hotel, which is annotated with documents, so it's a MongoDB annotation. And for this entity, it will create a Q hotel class, where Q stands for query. So for the hotel class, it will automatically generate a query hotel class. And then we can use those auto-generated classes to perform typed queries. So you can see that the process is, it's not that straightforward. But once you set it up, you can see that it's a really powerful tool to use when you have really complex queries. Okay. Now, where were we? Okay, we added the Mongo QueryDSL, and now we need to add the plugin as well. So I'll copy it from here. Okay, so we have this plugin. You need to be careful for the version. So the plugin's version is 1.1.3, and then here you also need to specify another dependency, and the versions need to match. So this QueryDSL apt, needs to match with the QueryDSL MongoDB in terms of versioning. So if you have 4.1.3 here, you need to have 4.1.3 here as well. And this is something that gave me a lot of headache. But once you have it running, then it's pretty okay. And you can see we have an output directory, and in this output directory, this is where the generated classes shall be placed. Okay. Because now I have this, we have modified our POM file, and once we use Maven, it will generate some query classes. And the last thing that we need to do, we need to go to our hotel repository, and we need to extend another class called, I forgot the name, but I think it's called, okay, QueryDSL predicate executor. Okay, so it's a pretty fancy name of hotel. Okay, and what this interface does, it will extend our hotel repository with additional methods that allow us to use the new query classes that will be generated. Okay, so let's use Maven and see if our setup works. Okay, so I'll say package. Okay, so everything appeared to work, just fine. And now you can see we have targets, and we have these new classes, okay, QHotel, QAddress, and QReview. Okay, so these are the generated classes that were created by the QueryDSL generator, by the QueryDSL plugin. Okay, now that we have this set up, let's see this QueryDSL in action. Let's start with a simple filter. Let's search for all the hotels that reside in a specific country. So in effect, we'll create a filter similar to this one, but instead of searching for hotels in a given city, we'll search for hotels in a given country. And of course, we will not use the query annotation and the Mongo query language, but we'll use the Mongo QueryDSL classes that we've just generated. Okay, so we'll create a new method. It will return a list of hotels. We'll call the method getByCountry. Okay, and of course, we need to use a path variable, which will be called country, and is going to be a string country. Okay, and now we need to define our first filter. So we'll use the QHotel class. We need to make an instance of it, and we need to pass in a name. Now this name is just for identification purposes, but so it really doesn't matter what you type in here. And now we can define our first filter, which will be a Boolean expression, but you need to use the Boolean expression from this package, from com.querydsl.core.types, because there's another one in JavaFX beans binding. Okay, so Boolean expression, we'll call it filter by country. Okay, and using this QHotel object, we can then access all the fields of our hotel entity, and we can perform filters on them. So you see, I can access address, for example, or I can access reviews, or I can access the price per night. So this generated class allows me to make typed filters based on the hotel entity. And what I want to do is I want to say, okay, I want to filter by address and then country, and then I want to apply an equality operator, and I'll pass in the country that is bound to my path variable. Okay, we now have our filter, but now we need to execute it. We need to pass this filter to our repository somehow. And this is where this interface, QueryDSL predicate executor, comes in, because by extending this interface as well, we get a findAll method that where we can pass in our filters. So now we can say list of hotels, and this is, we can use our repository, and we can use findAll, and inside the findAll method we can pass our filter as argument. Okay, and we need to cast it as a list. Okay, and now we can just return our hotels. Okay, so in effect there are three, more or less, two steps or three steps. We need to create a query class. In our case it's it's QHotel. Using this query class, we can then create our filters. And then using the repository, we can pass the filters in there to the findAll method. And that's it. This is a typical approach for this QueryDSL library. Okay, and before we test them, I want to create another one, a more complicated filter. Okay, but let's also add the get mapping here, and we'll say country dash country. Let's say I want to filter by multiple criterion. Okay, I want to find all the hotels that have a price per night less than a given value, but that have at least one review with a rating greater than 7 or 8, for example. So I want to find best buys, hotels that have a decent price but that have at least one review with a high rating. Okay, and this is a perfect scenario for this QueryDSL syntax. So we'll create another method that will return a list of hotels. We'll call it getRecommended, and we'll not pass in any additional variables here. Okay, so let's define our max price. Okay, I say it's 100, and then let's also define our minimum rating, and let's say it's 7. Okay, nice. And now we'll use the same approach. So we need to create a query class. So QHotel is a new QHotel, and we need to give it a name. Now that we have this query class, let's create our filters. And now we'll have two filters, one filter for the max price and one filter for the minimum rating. Let's start with the first one. Again, we'll use Boolean expression. Let's say filter by price, and it's QHotel price per night, and we can say less than, and here we can pass in the max price. Okay, and now we can create our second filter where we filter by rating, and we can say QHotel reviews, and we can say any, and now we can say rating greater than, and we need to pass in the minimum rating. Okay, and this is our second filter. We want if any review has a rating greater than 7, and if the hotel has a price per night less than 100, then this is a good offer and this is a recommended hotel. Okay, and finally we need to apply these filters in our repository. So we have list of hotels, and we can use our repository, and we can say find all. And now let's see how we can combine these two filters. So let's say filter by price, and then we can use the AND operator. And now we can pass in a different predicate, which is filter by rating. Okay, we have to cast this to a list. And now we have our list of hotels that we can return from this method. Okay, so again, it's the same approach, only that this time we used two filters and we've combined them in the find all method, but it's pretty much the same thing. Okay, I'll just add in these comments so that they remain here, for later. And now that we have defined these two methods, we can test them, but before we test them, I also need to provide a mapping for this one, recommended. Okay, so we have created two more controller actions that use the Mongo QueryDSL, and now we can test them. I fired up the application, and now we can test these two methods using Postman. Okay, we have to create a new request page. So we'll test the find by country method first. So we'll go to localhost 8080/hotels country, and we'll pass in Italy because I think we have a hotel there. We'll click send, and you can see we get a hotel that is in Italy. Okay, so the first one works, and now let's test the recommended hotels action. Okay, we'll create a new request. It's localhost 8080 hotels/recommended. And before we execute it, let's see what hotels we have in a database. So our filter, okay, so basically only IBIS matches this criteria because the other hotels have a price that is greater than 130, than 100, and Also, this one doesn't have any review, but IBIS matches both filters. So it has a price per night less than 100, and it also has one review that has a rating greater than 9. Okay, so we know what we should get after we run this method. Okay, we'll click send, and okay, you see that everything is working. Cool. I think we've covered pretty much everything for this tutorial. You'll find all the source code on GitHub. You can see the link in the description of this video. Do remember, however, that in order to run this application, you need to have MongoDB already installed. Okay, if you've enjoyed this video, please hit the like button and share it with your friends. You can find more software development tutorials on my blog at www.romaniancoder.com, and you can also follow me on Facebook at Romanian Coder. Have a great day and write amazing code. Goodbye.